There we go. What was I saying? I forgot. Oh, yeah, legs of a chair. So, yeah, if we're talking about like a chair where the legs are straight up and down, perpendicular to the ground, yeah, those would be parallel lines too. So I just wanted to quickly review what parallel lines are because we're going to be talking about them a lot. This image right here should be burned into your memory, okay? We're not only going to talk about this exact image for the next like week and a half, 2 weeks, but every math class you go to after this will touch on this idea just a little bit, okay? And you're going to be building on it as you move through high school. So let's lay some nice foundational groundwork today. So, line J and line K. Let's go ahead and take a look at those real quick. Here's line J, and there's line K. Now we just went over this, but how can we define lines J and K? What can we call those two lines? Parallel lines, exactly. And all that means, is there a question over there in the front? Jordan, is there a question, guys? Okay. So yeah, again, parallel lines, they have the same exact slope, right? And we can denote when two lines are parallel by doing this. Go ahead and draw this on your diagram. Two little arrows on line J and two little arrows on line K. Now what those little hash marks mean is that these two lines are parallel. We kind of talked about this with our triangle unit before, but math pictures that are, printed or in front of us, they're not always precise when it comes to the measurements. Gentlemen, get it together. Math drawings aren't always precise when it comes to their scale and their measurements. So if we have a nice symbol here that says, hey, these lines are definitely parallel, then we know that we're dealing with parallel lines, okay? Now the line that is cutting through these parallel lines is called line M. Line M, right there. And line M is what we call a transversal. Anyone ever heard this term before? Maybe it's been introduced a little bit, but probably not too much. A transversal is literally just a line that cuts through parallel lines. So there's really no more explanation I can give to that. It's just this line that cuts right through. It's kind of like, if you're thinking about this as like a highway, right, and you're over here on the left lane and you got to exit right away, you just cut across all those lanes so that you're able to exit. That might make more sense when you guys are driving, but it's okay. So we got a whole lot of angles here that are formed by this transversal cutting through these parallel lines. We've got one angle here, 3, 4, 5, 6, 7, and 8. So when we have parallel lines that are cut by a transversal, we get 8 very interesting angles. All 8 of these angles are going to be one of 2 numbers, okay? So let's break down each of these relationships one by one. I will say before we start that this is going to be a tiny bit confusing at first. Even if we have, strong math confidence, all of these ideas sound so similar that it makes it kind of hard to discern which is which. So let's just go ahead and start. This first note, angles 1, 2, 7, and 8. Let's go ahead and highlight those. 1, 2, 7, and 8. I just drew over them in pink. We call those exterior angles. Anyone know what exterior means? Exactly, outside, right? If you're on the exterior of this building, then you're outside the building. So 1, 2, 7, and 8 are all angles that are on the outside of those parallel lines, right? If we were to take 2 Post-it notes and cover up the outside of those parallel lines, 1, 2, 7, and 8 all disappear. You guys see that? So those 4 angles are all exterior angles. What do you think angles 3, 4, 5, and 6 are going to be called then? Interior angles. That's right. 3, 4, 5, and 6 are all interior angles because they fall on the inside of those parallel lines. Give me a thumbs up if you see the difference between exterior and interior angles. Okay, good, good. So we got 4 interiors and 4 exteriors. Now let's get a little bit more specific. Angles 1 and 8 are called alternate exterior angles. Let me write that down. Alternate exterior angles. And what this term alternate means is just that they are on opposite sides of the transversal itself. So let's take a look up and find angles 1 and 8. Here's angle 1, there's angle 8. In blue there. We can see that these are both exterior angles. They're on the outside of our parallel lines. But more specifically, they're alternate exterior angles because if we cover up the left side of our transversal, angle 1 goes away. And if we cover up the right side of our transversal, angle 8 goes away. You guys see what I mean by that? Yeah. So alternate just means they're on opposite sides. Okay? So like how an alternate dimension is one that's outside or the opposite of our dimension. Not that there are alternate dimensions, but if there were, that's what they'd be. Yeah.
So is 7 and 2 also alternate exterior?
That's right. 7 and 2. Here's 7. I'm not going to draw on it because we still got more to go. But yes, 1 and 8 are a pair of alternate exterior angles. So are 2 and 7. Right? They're both outside the parallel lines, but they're on opposite sides of that transversal line. I'm going to take like 30 seconds just to let your brains soak that in because it's about to get a little bit more confusing. So let's make sure we're understanding that. If you have questions, please make sure you're asking them as we go. Because at the end, it's all going to pile up, and then you're not even going to know what questions to ask. So think about it for a second. The interesting thing about alternate exterior angles is that, let me get a highlighter here. Alternate exterior angles are congruent. Again, what does congruent mean? Equal. They're the same. Same angle measure. Alternate exterior angles are congruent. So if angle 1 is 60 degrees, what's angle 8 going to be? 60 degrees, right? They're the exact same angle measure. And if we look at this diagram, again, I said drawings aren't always precise, but what type of angle is angle 1? Is it obtuse, acute, right, or straight? Obtuse, right? What type of angle is angle 8? Obtuse as well, right? Angles 1 and angles 8 are both obtuse. That doesn't, here, let me clarify this, or let me think. So, just because they're both obtuse, that doesn't necessarily mean they're congruent, but if we're looking at this image and we're trying to find two angles that are equal, we're probably going to go with the two obtuse angles that look somewhat the same. You guys see what I mean by that? Yeah. Sorry, that was not a very good explanation, but we'll jump back in here with the second one. So let's take a look at angles 3 and 6 now. Angles 3 and 6 are called alternate interior angles. This is why I said it's going to get confusing, because now all these names are starting to sound the same. Alternate interior angles. Let's find 3 and 6. Here's angle 3. There's angle 6. again, we can see that they are both on the interior, or the inside, of our parallel lines right here in pink, 3 and 6. I'll try to move this up. Right, 3 and 6 are on the interior, but they're on opposite sides of the transversal. If we covered up the right, or if we covered up the left side, angle 3 disappears. If we cover up the right side, angle 6 disappears. So that's why they're alternate. But in this case, they're on the inside, so they're alternate interior angles. Lucky for us, alternate interior angles are also congruent to each other, meaning they are the same exact angle measure. So let's take a look at 3 and 6. What type of angle is angle 3? Is it acute, obtuse, right, or straight, everybody? Number 3? Everybody? Okay, that's like 4 people. I want to hear everybody. What type of angle is number 3? Acute, right? It's less than 90 degrees. What about angle 6? Also acute, right? So anytime we're talking about these angles, all the obtuse angles are congruent, and all the acute angles are congruent. We'll confirm that here with our next couple of definitions. So alternate interior, they're both on the inside of our parallel lines, but they're on opposite sides of the transversal. Now, 3 and 5, let's take a look back at our diagram real quick. Angles 3 in lavender and 5. Are 3 and 5 interior angles or exterior angles? Interior, right? Now, are they on opposite sides of the transversal, or are they on the same side of the transversal? They're on the same side. If we cover up the right-hand side, we can still see angles 3 and 5. So, we're going to call these same side interior angles. Very aptly named. It's exactly what they are. They're on the inside of the parallel lines, and they're on the same side of the transversal. Okay, we'll take a second to let that resonate. So let's take a look back up at angles 3 and 5. Again, what type of angle is angle 3? Acute, obtuse, right, straight? Which one is it? Acute, right? Great. Now what type of angle is angle 5? Obtuse. Now if we have one acute angle and one obtuse angle, is there any possibility that those angles can be congruent? No, right? They're not the same size. This angle is very clearly larger than 90 degrees, and this angle is very clearly smaller than 90 degrees. So they're not going to be congruent, but what they are going to be is supplementary. Supplementary. Which means that they add to 180 degrees. So angle 3 plus angle 5 equals 180. Okay, that's same side interior. Are we ready for the next one? Okay. Everybody still with me? Okay, cool. It's only been 14 minutes. Hopefully we're still with me. We should probably finish this before 20, so. Now let's take a look at angles 2 and 6. What color should we do this in? Let's go this like orangish thing. Angles 2 and 6. Let's highlight those. Here's angle 2. There's angle 6. Now, are angles 2 and 6 on the same side of the transversal or opposite sides? They're on the same side, right? If we cover up the left, we can still see angle 2 and angle 6. But what do we notice about the interior and exterior of these two angles? They're different, right? 6 is on the interior, but 2 is on the exterior. We're going to call this type of angle relationship corresponding angles. And just like our alternate interior and exterior angles, corresponding angles are congruent as well. So angle 2 is equal to angle 6. And we could tell just by looking at the diagram that that is true. Angle 2 is an acute angle, just like angle 6. So we know that they are congruent. They're the same angle measure. One interior, one exterior, but they're on the same side of the transversal. Now let's kind of do the opposite. Angles 1 and 4, let's go back up. In purple, here's angle 1, there's angle 4, and that relationship actually looks kind of familiar, doesn't it? Angles 1 and 4. What do we call that relationship? Vertical, exactly. Vertical angles. Now, why are we bringing up vertical angles if we've already talked about them yesterday? Because of their similarities to corresponding angles. Let's take a look. In both instances, they have one angle on the inside and one angle on the outside. Right? If we take a look at 1 and 4, angle 1 is on the exterior, but angle 4 is on the interior. The difference is they're on opposite sides of the transversal as opposed to the same side of the transversal. Opposite sides. But they are still congruent to each other. But we know that already. Vertical angles, we just set them equal to each other. That tells us that they're congruent. And there we go. There's 5 new angle relationships. Alternate exterior, alternate interior, same side interior, corresponding, and vertical. Technically only 4 new ones because we already knew vertical. But those are the 5 angle pairs, angle relationships that we're talking about with these parallel lines. Now I know that's a lot. I know that's a lot of different but similar concepts to kind of wrap your head around. So we're gonna take 2 days on this. We're gonna talk about this today, and we're gonna continue on with it tomorrow. But before we get our worksheet, what questions can I answer about this? I know that there are definitely questions. Maybe they'll come up later. But quick show of thumbs, how do you feel about that rundown of vocabulary? Thumbs up if we're like, oh, I get it, this sounds about right. I'm expecting a lot of thumbs sideways, which is okay. That's where we should be right now. Good, okay. So let's get some practice here. Let me get this tape out of the way. So this is what worksheet 71 is going to look like. Instead of having just, one diagram with a bunch of nonsense going on, we're breaking it down. So you're going to take a look at what you got. You're going to, just like yesterday, first identify what relationship do we have, and then you're going to find the measure of the missing angle. Okay? Now, we didn't learn how to find the missing angle. How are we going to do that? There's only 2 options. They're either going to be congruent, so you just write the same number, or they're going to be supplementary, so just subtract that number from 180. Hopefully you guys see how each day we're building on those same ideas that we talked about, just sprinkling in new information as we go.